The objective of this lesson is to have students be able to multiply with 9 as a factor. To review, just as students in second grade see 9 as 10 minus 1 for addition and subtraction fluency, students in third grade now use the same understanding to learn multiplication by 9 as 10 groups minus 1 group. In this lesson, students review the need to decompose numbers strategically when using the distributive property. For example, if I multiply 5 times 6, I could decompose my 6 into 4 plus 2, and then I distribute my 5 and make it 5 times 4 plus 5 times 2, which equals 20 plus 10, or 30. Another example might be using halving and doubling. If I have 5 times 6, but this time I divide it into 3 plus 3, then I distribute my 5 times 3 plus 5 times 3, which gives me the double of 15 plus 15, which again equals 30. Let's look at how we can decompose the factor 9 to help us with our 9 times facts. Let's try 4 times 9. First, let's draw an array which represents 4 by 9. 4 rows with 9 in each row. How could you decompose these 9 columns into smaller arrays? Some students might decompose 9 around addition facts for 9, such as 1 plus 8, 2 plus 7, even 3 plus 6, or possibly 4 plus 5. These help to reinforce the distributive property for students as they solve 4 times 3 plus 4 times 6, which is 12, plus 24, which equals 36. Or for this one, 4 times 4, which equals 16, 4 times 5, which equals 20, and 16 plus 20 again gives me 36. This suggestion is noteworthy because it shows that the 9 times products are the 3 times products tripled. Another strategy that is most efficient, but the students may not have thought of, is to decompose 9 into 10 minus 1. The reason this is the most efficient is students are likely fluent and comfortable with times 10 facts. To help visualize this strategy, let's add another row to our 4 times 9 array. Now, 4 times 9 becomes 4 times 10 minus 1. We use our distributive property, 4 times 10 minus 4 times 1, which equals 40 minus 4, which again equals 36. Let's try this strategy again with 5 times 9. Let's draw an array that's 5 rows by 9 across, and then I'm going to add an extra row. So now it becomes 5 times 10 minus 1. I'd use my distributive property to distribute my 5. 5 times 10 minus 5 times 1, which gives me 50 minus 5, which equals 45. So 5 times 9 is 45. When you look at both examples of making 9 into 10 minus 1, do you see any patterns? Let's look at a multiplication chart and look at all the products for 9s and 10s. Can you see that the answers to our times 9 facts are the same as our times 10s facts minus 1 group? For example, you can see that 10 times 5 is 50, but 9 times 5 is 45. 45 is one group of 5 less than 50. 10 times 7 is 70. 9 times 7 is 63. 63 is one group of 7 less than 70. Another pattern students might discover with the times 9 products is immediately knowing the digit in the tens place. It looks like it's one number less than the number of the groups. For example, when looking at 9 times 6, the digit in the tens place is 1 less than 6. Looking at 9 times 8, the digits in the tens place is 1 less than 8. Looking again at our 9 times facts, what is the sum of the digits? 9 times 2 is 18. What is the sum of 1 plus 8? 9 times 3 is 27. What is the sum of 2 plus 7? 9. Is that true for all the times 9 products on the chart? Do all the digits of the product add up to 9? Not only is the sum of the products 9, but what's happening to the ones place compared to the tens place? 18 is 1 10 and 8 ones. 27, 2 tens and 7 ones. 36, 3 tens and 6 ones. The digits in the ones place decrease by 1 as the digits in the tens place increases by 1. So many interesting patterns among our 9 times facts. In this lesson, students learn strategies when multiplying with 9 as a factor.